All right. Hi guys, how are you doing? All right. So first of all, let me welcome you guys to Unacademy JEE English. This is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this channel, everything is being taught to you completely in English, so that you're not feeling left behind because of extensive Hindi usage, which you normally find on YouTube. All right. So this series that I host daily is for 2020 aspirants. All right. So today is the lecture 6 of fluid mechanics, and today we'll be talking about surface tension. All right. So before we move forward, let me introduce myself one more time. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and I have been teaching physics for JEE for almost 8 years now. Now, all my previous experience has been in offline setups, and there I have taught at some of the biggest institutes in the country for JEE coaching industry, of the JEE coaching industry. I myself was JEE rank 447, and I've already coached many students to top ranks in the offline setup, and I hope I can continue doing that with you guys here in this online setup. Hi Moisha, how are you? Alright, so moving forward, let's also talk a bit about the Unacademy subscription. Alright, and the benefits that this one comes with. So your Unacademy subscription comes with benefits like live classes, and you get to interact with your educators. So this makes you feel like you are in a regular offline coaching setup. Alright, so you don't miss, there is no difference between the online classes that are happening on Unacademy and the offline classes that you're used to. These classes also have live polls and leaderboards, so which make the classroom very interactive, highly interactive. And then, of course, you have test series and analysis, and you have live doubt clearing sessions. So trust me, this is a huge boost for your JEE prep, because a lot of students are very confused about where to get their doubts solved. So your doubts will always be taken care of on your Unacademy courses. Alright, because they have this compulsory feature that after every 3 sessions, one session has to be a live doubt clearing session. Alright, and on top of this, Unacademy is getting you India's best educators on a single platform. So for all these benefits, everything is getting taken care of. So it's definitely worth checking out this subscription. Now, how do you get this subscription? Very easy. You install the Unacademy app. Once you have done that, you go to the plus section, you select your goal as IIT JEE and click on the get subscription button. Now, when you're getting your subscriptions, you will also realize that all these amazing features are available to you for a very reasonable and affordable price. The pricing has been kept as small as 36,000 for 24 months, which is hardly 1,500 a month for 2 years. Imagine. Yeah, I know people are paying more than this for their tuitions in class 7th and 8th. Alright. And even the 12-month subscription comes to about 2,500 a month, which is again very affordable pricing. So I would advise you, if you are looking to get a subscription, try one of these. And trust me, at these prices, you have almost absolutely nothing to lose, because the kind of quality that you are getting, I think it's a must. This subscription is a must-have. Alright, and this subscription would be made even more affordable if you use my code RDLIFE to get it. This code not only gives you entire access to all the awesome features of the Unacademy Plus, it also gives you an additional 10% off. So already very affordable pricing would be made even more affordable with this code. Now, for those of you who are following us on the JEE English channel, you can join us on Telegram using the link shown above, so that you're not missing out any of the notifications for all the sessions and lectures happening on the JEE English channel. Alright, so let's move forward and let's get started with today's discussion, which is about surface tension. So today we'll be finishing fluids, by the way, and from tomorrow we will be starting thermodynamics. Okay. So what do you know about surface tension? We already started this discussion yesterday. We talked about surface tension is the force because of which the entire free surface of the liquid behaves as a stretched membrane. Alright, so free surface of the liquid is the liquid surface which is in contact with the air. Alright, now why does it happen? This happens because the molecules have an asymmetry of forces acting on them. The molecules of surface have asymmetry in the forces that are acting on them. So to counter this asymmetry, the surface molecules have huge attractive force amongst themselves. And that requires energy also, which we called surface energy. And by the way, the surface tension force would act on all free surfaces, but then all the surfaces which are the solid liquid contact surface also, or the liquid air contact surface also, But mostly we only talk about the air liquid contact surface because that is the surface that we will mostly deal with. Okay. So, based on the discussion that we had yesterday, I thought it would be nice to start with some practice problems. So, why don't you guys try this problem? Hello, Rohit. How are you? P. Hitesh says solids. When will you start or it completed? Solids. Okay, so you mean elasticity and stuff. That's a very simple topic. I thought it'll be more worth covering a topic like thermodynamics first. All right. That's a very small topic, elasticity one. I think you can easily revise it on your own also. But if you want me to take class, maybe I will take it later. But I wanted to finish important topics first, like thermodynamics. All right, that's a huge topic. It will help you in your physics as well as your chemistry, and a lot of questions from JEE are asked from that topic. All right, Hitesh. All right, so why don't we discuss this question that we have? Here you've been told that two soap bubbles A and B are kept in a closed chamber where the air is maintained at a pressure of 8 Newton per meter square. The radii of the two bubbles A and B are 2 centimeter and 4 centimeter respectively, which have been shown to you in the figure. The surface tension of the soap water used for making these bubbles is 0.04 Newton per meter. You have to find the ratio Na is to Nb, where Na and Nb are the number of moles of air in the bubbles A and B respectively. You can neglect all effects of gravity. Alright. Okay, so Moisha is already trying. I hope all others are trying as well. Alright. So by the way, you guys can let me know if you really want solids to be discussed. Then maybe I can start that tomorrow. I mean that's basically a one lecture discussion or maximum two lecture discussion. But I thought it is more important to cover more important topics like thermodynamics. So you can let me know about your views in the chat. Is this from thermo? Oh, not really. This is from surface tension, as you can see. That yeah, but you will need to use P1 V1 equals P2 V2 PV equals nRT equation also. So see, this is an advanced problem, by the way. This is a problem from JEE Advanced. In JEE Advanced, what happens is when IIT people ask you questions, they ask you questions such that in one question they can test multiple concepts. All right. So that is why such a question has been asked, where basic gaseous state knowledge and both surface tension knowledge are required. All right. So most of the problems in advanced would be like this. Okay. Most of the advanced problems would involve multiple concepts. Alright, but this should not be too difficult because the only concept of thermodynamics that you will be using is the ideal gas equation. Okay. Alright. I hope, by the way, others are also trying along with Moesha. Rohit Rao, what class are you in? Okay, Moisha says 1:6. All right. I actually don't remember the answer right away. Okay, let me see. Why don't I check the answer? Okay, so Rohitra says 1:2. Let's see if that is correct. Okay, so yes, that seems to be correct. This was an integer type question. The correct answer is 6. NB is to NA would be 6. Well done, Rohit. All right. So what class are you in currently? And okay, so you're in class 12. So you'll be taking your JEE in 2021 then, I guess. All right, good to see. You solving the JEE advanced problems pretty easily. That is always good. Hi Chinmay, how are you? No. Why? So when are you planning to take your JEE? Okay. How about Moisha? Do you have an answer or should I go ahead and solve this? Please let me know if you have an answer. Otherwise, I'll go ahead and solve this. Yeah. So 2021 is next year. 2021 is next year. All right. So for those of you who don't know this series I host daily for this is meant purely for 2020 aspirants who are looking to revise their class 11 topics, and of course for also for 2021 aspirants who want to have a quick revision of their class 11 topics. All right. And for 2021 aspirants, so the students who are currently in class 12th, I am taking up another series also, which is live every Tuesday, Thursday, and Saturday. So there I'm taking up class 12 topics. There all the class 12 topics are being discussed from scratch. Similarly, I take another series for class 11 students on Monday, Wednesday, and Friday at 4 o'clock again. There, every class 11 topic is being discussed from the scratch. This is a revision class. Here we quickly revise the key concepts and then we focus more on problem solving. All right. So now you know, Rohit, that you can also join me on my class 12th segment. All right. And you can keep on following me here for revision of your class 11 topics. And if there is any particular topic that you want to revise from the scratch, if you think you couldn't understand that at all, then you can attend my class 11th lectures also for that. All right. So Rohit, you can also check out the previous lectures that I have we have uploaded. The Unacademy has uploaded. All right, wherein I have already discussed kinematics, Newton's laws, momentum, work power energy, rotation, and gravitation. Okay. All right. So Moisha is still trying. Okay, this is not that tough a problem. I think you're taking a little too much time. Okay, very simple problem. Okay. Shouldn't be taking this long. All right. All right. So I'll give you one more minute maybe. Okay, Moisha. And then let's go over the solution. Okay. So Chinmay, how have you been? So I hope you watched those videos that I told you to watch, my class 11 videos for basic maths, because I remember you did not understand differentiation and integration very well. So I have uploaded two videos for that also, basic calculus and basic maths for class 11 students. So I hope you have already watched them. Okay. All right. Okay. Thank you for letting me know. So that is very simple. So when you're talking about A and B, so let us assume that the pressure inside the bubble A is PA and that inside bubble B is PB. Now you know the external pressure. External pressure is 8. So you also know the surface tension and the radii, and you remember your formula from yesterday. If you remember your formula from yesterday, you will realize that PA would be P external plus 40 over R RA. Alright, so that will be 8 plus 4 into zero point 0.04, I think, yes, 0.04 over 40 over 8. 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 0.04 over 40 The radius was 2 centimeter. So again 0.02 in meters. Alright. Yep. So that'll give me my answer as 16. Alright, so PA I'm getting as 16. Similarly, PB would be equal to 8 plus 4 into 0.04 over 0.04. Alright, because the radius of bubble B was 4 centimeters. Alright, so this will give me my answer as 12 Newton per meter square. Alright, so I have the two pressures. Now there is nothing much left to do. I know PV equals nRT, so I can say PA VA equals NAR of T, R times T. Now I can imagine the temperature would be the same, alright, because the bubble inside the soap would take up the ambient temperature only, and the ambient temperature would be common for both of them, so the air inside both would be at the common temperature. Similarly, I can write that PB VB equals NB over RT. So you can divide these. When you divide this from here, you know that NB over NA. This is nothing but PB VB over PA VA. Alright, so that is now very simple. You know the values. This is 12 into the volume of B would be, again, I don't need to convert it now. I am not even writing 4 by 3 pi. Those will get cancelled. The ratio would be in the cube of their radii. So 4 cube, I can simply write this 4 cube, and here I can write 16 into 2 cube. Alright. When finding the ratio, I don't need to write 4 by 3 pi. Those will get cancelled. I don't need to convert it into meter. Those will also get cancelled. Okay, so if I have the correct values, yes, I seem to have the correct values. Alright, so let's see what this gives us. So this will be 3. This would be 4. So again, 1 4 would get cancelled from here and 1 4 from here. So this will also get cancelled. So yes, I am getting 6. So that is my answer. The ratio of the number of moles would be 6. Alright. So I hope you guys followed this and there is no confusion about this. So this is a previous year JEE advanced problem. I think it was asked in 2005, if I remember it correctly. Okay, so if there is no confusion about this one, so should we go ahead? Should we move to the next problem? Alright, go through the solution. Let me know if you have any doubt. Alright, great. So again, an IIT JEE problem, previous year JEE problem. I thought we will start our discussion with JEE advanced problems. Alright, so in this problem, you've been told a uniform wire having a mass per unit length lambda is placed over a liquid surface. The wire causes the liquid to depress by some y. You've been told you can assume that y is much smaller than a being the radius of the cylinder, as shown in the figure. You have to find the surface tension of the liquid, and you can neglect the end effects. End effects meaning the effects around the end of the spin. Alright. So why don't you try this? So I want all you guys to try this, and you can write trying in the chat to let me know that you're trying. Okay. So that I know how much time to give you guys. Alright, so please try, and also write trying in the chat to let me know that you're trying. Okay. So this is what is happening when you place a pin which has a mass per unit length lambda, then it depresses the surface like this, and it has been assumed, this is an approximation. Alright, so should I be scared if I could not solve a previous year problem? No, not at all. Anyways, that was a simple problem. I don't know where you went wrong, why you couldn't solve. This is a simple problem though. So all you need to do is just figure out where you went wrong. That's about it. And I don't think it should be an issue. Alright, so don't worry about it so much. It happens sometimes. You can't be worrying about every time you couldn't solve a problem. Trust me, that is one thing I also wanted to talk to you guys before you are taking your JEE. Maybe I'll plan a special session on this Saturday. Yeah, before you because you guys I think have your JEE exams. Yeah, the very next week, right? So I also wanted to have a session with you guys on Saturday about your mental preparation. Trust me, that matters a lot. All right, and unfortunately, that is where I faltered during my JEE. I was very well prepared for my subjects, but I think there was some part of my mental preparation missing, because of which I couldn't do as well as I wanted to in my JEE paper. All right. Turns out I scored the minimum in physics in my JEE out of chemistry, maths, and physics, while physics was my strongest subject. So, yeah, some things went wrong and I ended up scoring the lowest in physics. I scored higher in maths and highest in chemistry. And the usual trend would be that I would always score the highest in physics, then chemistry, then maths. So that day, yes, I think the pressure got to me and a few things went wrong. So that is why I wanted to talk to you guys also about your mental preparation and how to handle the examination room pressure. All right. All right. So can I have any answers? Okay. Yes, I know. And we used to have a subjective paper with a pen and a paper, so you can imagine in a subjective kind of a setup where you have to write your proper solutions. If you are if something goes wrong, you end up doing very bad. Okay, so Rohit says a lambda g over 2y. Let's check this answer if that is correct. Okay, so all right, a lambda g over 2y, that seems to be correct. Very well done. Yes, that is correct. That is the correct answer. Very well done again, Rohit. All right. Okay. So, Rohit, are you going to any coaching or are you studying on your own or are you studying online? Are you studying in an offline setup, an online setup, or self studying? Because it's nice to see such quick answers for JEE advanced problems. So, yes, you're doing something right. Okay. I have taught there too, though in the offline one, of course. Before that, I was with Fiji for the longest duration of my career, and then yes, for some time I was with Akash also. Before moving online, that is. All right. Okay. So Moisha, how about you? Are you close to an answer? So again, this is very simple. Don't worry about it too much. This should be simple. Just remember the concepts we discussed yesterday, and it should not be too much of a problem. Got it. All right. That is good. That is good to see. Alright, so this is a very easy problem. What you need to do is just think about the FBDs. So here is your pin. So it has attention, self-attention T acting from here, T acting from here. You can divide these T into two components. Alright, so one this component and one this component. So if this angle is theta, so this is theta. So the net upward force, the net force on the rod pin would be upwards 2t sine theta, and downwards it would be 2t sine theta into L, and downwards it would be mg. Alright, so that is it. So if you consider that the length of the pin is L, then this is the FBD that looks like. For equilibrium, you have to equate both these forces. So it's very simple now. So all I need to do is I need to say that 2t sine theta L should be equal to mg. Now mg can also be written as lambda L times g. So I can now write this 2t sine theta L equals lambda L times g. So L will get cancelled. So I am getting 2t sine theta equals lambda g. Alright, now all I need to do is make use of the fact that I've been told that y is much less than a. So if I look at this triangle, so just look at this triangle. So if you look at this triangle, in this triangle sine theta is nothing but y over a, right? So here I can see sine theta is y over a, and since I've been told y is much less than a, I can assume that theta tends to 0, because sine theta tends to 0, sine theta tends to 0, so theta tends to 0. I can use the small angle approximation. So therefore I can write, therefore sine theta can be approximated to theta. Alright, so which gives me 2t times theta or sine theta. Okay, sine theta was in any case this y over a. This would become equal to lambda g. So there I have my answer. The answer is t equals lambda a g over 2y. Alright, that is my answer. Okay, the idea is that I can think of this as a flat triangle only. Alright, so let's move forward. How is Akash material? Okay. So sorry, I missed. When will you teach magnetism? Okay, Sabresh. Maybe I'll plan a special class on the app for magnetism. Okay, I was planning to cover rotation on the app this week. So maybe next week, if that works, Sabresh. Jay Akash says, me too, Akash Institute student, but also an Unacademy. Okay, how is Akash material? Is it okay for advanced? So alternate way. Alternate way. No, this is a very simple solution in any case. Why do you need an alternate way for this? Okay, most of the coaching materials are alright only. Most of them are fine. Most of them are alright. They're okay. Alright. You have so much material in any case. I think all the material is available. So you can try anyone. It's fine. Okay. Alright, so let's move forward and let's discuss some more theory. So let's talk about cohesive forces. So what are cohesive forces? The force of attraction between same kind of molecules is called cohesive force. Alright, so what are these results of these cohesive forces? So if you have water and water molecules, so the water molecules will attract each other with a certain force. That is called cohesive force of water. Similarly, if you had mercury would attract them each other. So this is called such forces are called cohesive forces, which are acting between same kinds of molecules. Alright. So the effects of these cohesive forces is that if you bring two drops of a liquid together, they will coalesce, they combine to make a single drop. That happens due to the cohesive forces. The cohesive forces are bringing them together. Similarly, it is very difficult to break a drop of mercury into small droplets because they have very large cohesive forces. Alright. In Unacademy app, who are the teachers who teach in English? Okay, I think right now only the JEE English team is teaching in English. Okay, Sabresh. Only the JEE English team I think is teaching in English as of now. I am not aware of anybody else taking classes in English. Okay, Norman says, what is viscous drag? Okay, I Norman, you can watch yesterday's video that I had. That was about viscosity. All right, so you can watch that. Similarly, there is something called an adhesive force. Now we realize that if similar molecules are attracting each other, the force between them is called cohesive. This is the other way. This is one kind of molecule attracting another kind of molecule. So one type 1 molecule attracting type 2 molecule. The force that they have are called adhesive forces. By adhesive, you know, adhesive means to join, to glue two things together. All right, so that is why these are adhesive forces which will glue two kinds of different substances together. Okay, all right. Next, the force of attraction, as I said, the force of attraction between molecules of different kinds is called adhesive force. Adhesive force enables us to write on the blackboard with chalk. So when somebody is writing on the blackboard with chalk, why does the chalk stay or stick to the board? That is adhesive force. Okay. Similarly, due to the force of addition, the water will wet a glass or a plate, you know, while mercury does not. So if you have a glass and if you have a plate and if you pour water on it, and even if you keep it vertical, some of the water would have been stuck. So you will say it has made the plate wet. However, if you take a plate, pour mercury on it, and the moment you make the plate vertical, all the mercury would slip down and there will be absolutely nothing left there. It will be left dry. All right. So that is again responsibility of adhesive forces. If there are adhesive forces which are strong between two substances, then they will stick together. If the adhesive forces are not strong enough, then they won't stick together. All right. Next, let's talk about the angle of contact. So whenever, isn't friction responsible for us writing on the blackboard? No, why is it sticking? Why is it sticking? Why is it sticking? Friction is responsible for breaking your chalk particles. For when you're moving, the chalk particles are initially resisting and breaking because of the chalk, but they are sticking. They are sticking because of the adhesive forces. See, okay, so let me show you something. Let me show you something. If I take this phone, if I push, then friction stops it, right? If I remove the push, what happens? What happens? It will fall down. Why? Friction requires a normal reaction. Alright, so I have to provide a normal reaction, no? For friction to take effect. But who's providing the normal reaction to the chalk that is stuck to the board? Think about it. So that is not stuck there due to friction, no. It is stuck there due to adhesive forces between the board molecules and the chalk molecules. Okay, I hope you got that. Let me know if you got that. Friction wouldn't have been able to hold anything unless normal was applied. Yes. Okay. Next, as I was saying, when a liquid surface touches a solid surface, the shape of the liquid near the contact generally gets curved. Now the angle between the tangent planes of the solid surface, which lies inside the liquid volume, and the liquid at the contact point is called angle of contact. So what you're doing is, you identify the point of contact between the solid and the liquid. Now you draw the tangents of both the planes. So this is the tangent on the solid. This is the tangent on the liquid. Now there are two angles that you will see between these two. So this angle, the angle which lies inside the volume of the liquid, this is called the angle of contact. Okay, so this is angle of contact. Alright, it was already shown to you on the other side. In any case. Alright, so this is the angle of contact. Now, you will realize if cohesive forces between the liquid molecules are greater than the adhesive forces, then the contact angle would be obtuse. So in case of mercury, you can see that. In case of mercury, what is happening is, you talk about the molecules which are there at the boundary. So they are being pulled by the molecules which are below of the solid, and they are also being pulled by the molecules of the liquid which are on the side. So if the pull of this is higher, then you will see that this angle is less than 90. If the pull of these molecules is higher, which is in this case, the pull of these molecules is higher than the pull of this, then you will see that the angle is greater than 90. So angle is greater than 90. Alright, so let me use theta. So theta greater than 90 if cohesive forces are stronger than adhesive forces. Theta is less than 90 if your adhesive forces are stronger than cohesive forces. This is a special case where both become equal. If both just become equal, then it would stay like this. Okay. Alright, so the angle of contact between a solid and liquid decides the wettability, by the way. So what that means is, if the angle of contact is less than 90, then I already told you, this is the case when the adhesive force is higher. The adhesive force is higher than the cohesive force, which means something like water. So even if I poured water here, if the angle of contact is less than 90, that would mean there is a good amount of adhesive force between water molecules and the molecules of my hand. So even when I turn my hand, some water will get stuck here. Alright, because of that adhesive force, and we will say that the water is wetting my hand. So any liquid will wet a solid if the contact angle between the liquid and the solid is less than 90. On the other hand, if the contact angle between the liquid and the solid is greater than 90, then such a liquid will not wet the solid. Okay, so which is explained here also. Next, this also results in various shapes of meniscuses. So when you're pouring a liquid in a tube, so you must have noticed this. When you pour a liquid in the tube, there are three possibilities. One is this, another is this. The meniscus takes such a shape, and the third one is this. So there are three possibilities that can happen to the free surface of the liquid. It can either curve concave up or convex down or flat. So what is happening is, suppose, okay, you can see it here. So if your adhesive forces are very, very strong, so imagine what is happening. Imagine when you filled it with water like this. Now what is happening is that on the boundaries, imagine on the boundaries, all the molecules on the boundaries are getting attracted due to these solid molecules above them also, and they are getting attracted due to the water molecules below them also. Now if the adhesive force is strong, so what happens is that the solid molecules above will actually pull this entire outer layer of the liquid, and that is why this is what is resulting. This layer got pulled to the top, alright, and that is why you see that the entire meniscus turned like this. Similarly, if the opposite were true, if the cohesive forces were stronger, then these molecules or the liquid below would end up pulling these surfaces down. Alright, why? Because there is a disbalance of force. See, all the forces on these molecules, they are fine. They are here due to surface tension and the downward pull. But on the edge, again the surface tension also is not balanced, because the surface tension is not, there are not neighboring molecules on every side. So on this side, what happens is, on this side, there is a disbalance of forces. The forces are due to the adhesive forces of the solid above and cohesive forces of the liquid below. Alright. So when there is a disbalance of forces, this surface, the outermost surface, will start twisting up or down. Alright, depending on which force is greater. In case both the forces are absolutely equal, then it will remain flat. Okay. So this is why different meniscuses have different shapes. So let's read about this also once. So here it says that when the adhesive force between solid and liquid is more than the cohesive force between the liquid molecules, with molecules like, okay, so the example is, yes, glass and water. We know that the adhesive forces between glass and water is higher than the cohesive force between the water and water molecules. So what happens is that the meniscus takes up a concave shape, which you can see here. This is the kind of shape that it takes. And now what happens to the angle of contact? So this is the angle of contact. You will see this is less than 90. Alright. Similarly, if it's the other way around, if adhesive forces are weaker and cohesive forces are stronger, then the meniscus turns upside down, it becomes convex, and here you will see this is the solid angle. Okay, this is the angle of contact. Yeah, this is the angle of contact, which would be greater than 90. Okay, so that is how you will draw the angle of contact. Next, another interesting result is capillary action. This is also a result of surface tension. So what does that say? The surface tension causes elevation or depression of a liquid in a narrow tube. Narrow tubes are called capillaries also. Alright. In case of water, the glass capillary, water and glass capillary, the water will rise above. Why? Why is it happening? Because the molecules from above are pulling it out. Alright. So what they are doing is that they are curving the surface and pulling the liquid molecules above. Alright. Similarly, if you had mercury and glass, then this again, as I said, these guys at the top will feel an unbalance of force. Alright. So because of which they get pulled down by the molecules below. Alright, so this is what capillary action is. Either a liquid will rise up in the capillary or get depressed down. This is called capillary action. Alright, so mathematically you should know the relation. Okay, I'm not showing you the derivation because this is a revision class, but this is what the expression goes like. If the radius of the capillary tube is small r and theta is the contact angle, then the height to which the liquid rises. Okay, so this should be liquid, by the way. Okay, this is liquid, not water, not necessarily water. So any liquid column, the height would be 2t cos theta over rho rg, where t is the surface tension, theta is the angle of contact, small r is the radius of capillary. So as you can see here, it is the radius of capillary over rho g. Rho is the density of the liquid, g acceleration due to gravity. Alright. Now this can also be written as this, where capital R is the radius of curvature of the meniscus. Okay, so this is another very, very important result that you should remember, because a lot of JEE advanced questions are solved using this, that capital R equals small r over cos theta, where capital R is the radius of curvature of the meniscus, small r is the radius of the capillary tube, and theta is the contact angle. Okay, please remember this equation. This is very, very important. This gets used in a lot of JEE advanced problems if you look at their solutions. Now you will notice one thing interestingly. If theta is less than 90, cos theta would be positive, which would mean that liquid is rising. If theta is between 90 and 180, then cos theta would be negative, which would mean that the liquid is depressing in the capillary. Alright. So again, I'm not showing you the derivation, but you should remember this equation and you should also remember this equation. So these two are very, very important. Make sure you memorize them. Okay, so let me just highlight these. So this equation and this equation, they are must remember equations. Okay. Hi Mahendra, good to see you. Alright, now we're going to talk about two special cases. If the contact angle is 0 degree, then there is a correction that is added for the weight of the liquid in meniscus. So what you will notice is that in earlier case, when we derive this equation, what we say is that we draw an FBD of this section of the liquid, and we say that the forces acting on this are the atmospheric pressure from here, the atmospheric pressure from here. Again, why is the pressure atmospheric here? Because it is here also atmospheric. Pascal's law would say that on the same horizontal level, the pressure would be the same. And the surface tension force, alright, so force due to surface tension and mg. So how we're deriving this formula is that we actually make an FBD of this portion. We ignore this volume in the meniscus. So in this case, we are ignoring this, because it is very difficult to calculate the volume and hence the weight of the liquid in the meniscus. Alright, so that is what this formula is. It is an approximation, it is not very accurate. It has an approximation that the volume of the meniscus liquid is negligible. So please remember that there is an assumption here. Alright, now in special case of 0 contact angle, what I know is that this meniscus would become a hemisphere. Alright, if the contact angle is 0, then I can calculate this volume very easily. This would be volume of cylinder minus volume of hemisphere. Alright, so you consider this cylinder. So the volume of cylinder minus volume of hemisphere would give you the volume of this liquid, and you can include the weight of this liquid now. So in the special case, when the contact angle is 0, then if you add the correction of meniscus volume then this is the equation that you get. The actual height is the height which was calculated earlier minus r over 3, where r is the radius of the capillary tube. Again, I'm not showing you the derivation of this, but you should remember this. Mains people ask this. So this is important for mains. Okay, I keep on selecting pen. Let's write that, important for mains. Advanced people generally do not ask this. Okay. Now another special case is, suppose you use that formula. That formula gives you a certain height h to which the liquid should rise. Now if your capillary has a height which is less than this, then what happens? So if the length of the capillary is insufficient, that is what insufficient means. Insufficient means it does not have enough length to allow the liquid to rise in it. Then the radius of meniscus changes. Okay, so what is happening is, imagine, why was the liquid rising? Okay, that is what comes after calculations. That is what comes after calculations. I can show you the calculation, but I didn't want to. You can just remember this. What you're doing is you are adding this weight also. You calculate this weight. So if this is V dash, this volume is V dash, so V dash rho G plus this weight below, which is pi r square h rho G. This would be equal to 2 pi r T. Okay, this is how you will get it. You can try it on your own. Okay. So earlier what happens was, in earlier cases you were ignoring this. This was almost taken to be 0 in earlier cases. And that is why you had this. You equated these and you were getting that. And here again, I am not using cos theta because cos theta has become 1. Because the contact angle is 0. Okay. Shouldn't we put theta 0 in previous equation? No. As I said, in the previous equation, you were ignoring this. So if I do not ignore this, then I will have this. Okay, you realize h would be smaller than this. There would be a minus term also. Okay, so that is it. Yeah, but it is quite unlikely to be postponed in any case, since the Supreme Court has given the orders. In any case, I personally think that you guys shouldn't focus so much on whether JEE is getting postponed or not. Just keep on focusing on your preparation. All right. Anyhow, so as I was saying, if the length of the capillary is insufficient, then the radius of meniscus changes in order to prevent overflow. So the liquid will not overflow. However, the radius of or the contact angle will adjust itself, and you will have this equation. Now see why that is happening. Why that is happening is, why was the meniscus forming the way it was forming? So imagine if the liquid was like this. I told you that it is feeling two forces. So these molecules are attracting it up. The water molecules are attracting it down. Alright. So if the up forces are greater, then this entire was turning. Alright. The forces due to the molecules above would cause it to go up like this. But what happens once it reaches the top? Then obviously the forces, again, there is nothing above this to be able to pull this. So now you realize it can't get pulled so much. It gets pulled a little, and in this only the weight of this gets balanced. Alright, so that is why the angle now is slightly higher. The contact angle will become higher. Alright. The contact angle will automatically become higher because of, again, asymmetry here. Here earlier the forces were here and here both, because of which it is going higher up. Here only the forces are in this way, the forces of solids. There is no solid above to pull this. That is why the force is not as effective, and that is why the meniscus is not going that much up. It is not curving that much. Okay, so that is the logic behind the meniscus adjusting its shape, and it cannot overflow, by the way. It cannot overflow. Why? Also understand this. There is also a concept of energy. So when this when this liquid is rising in this capillary, where is this getting this PE from? Delta PE, where is it coming from? Where is this delta PE coming from? Alright, if liquid overflow, then it will violate energy conservation. Absolutely, absolutely. So let's try to understand how where is this potential energy coming from? What do you think? Where do you think this energy is coming from? Any ideas? Okay, so since you guys are not giving me any answers, so let me give you the answer. What happens is that not only liquids, yes, it is coming from the surface energy, that is correct. Not only the free surface of liquids have surface energy, but the surfaces of solids also have surface energy. So this also has surface energy. By the same logic, this also has surface energy. Any free surfaces of solids also have surface energies. So here what is happening is that the surface energy of this guy, the entire surface energy of this guy has gotten disappeared. So this would be equal to the surface energy of this guy. The surface energy of this entire surface, see, the solid ends up losing this much of free surface. Alright, the solid ends up losing this much of the free surface. So the surface energy that this solid had is what is getting transferred to the potential energy of this liquid. Alright, so that is the logic. Now that is why once the liquid reaches the top, it cannot gain any more PE. Why? Because there is no more free surface available for it. Every time it is gaining PE, it has to take up some surface, some free surface. Alright. So once it has already reached the top, there is no more free surface energy available which it can take to increase its PE, and that is why this does not overflow. It cannot overflow. The only option it has to adjust the radius of its meniscus or the contact angle. So why don't we try a problem now? Alright. So this is most of the discussion that I wanted to have about capillaries in any case. So let's just try some problems. Okay. So you've been told mercury has an angle of contact angle of 120 degree with glass. Okay, I think it is usually 135, but okay, this question says 120, so we will stick to 120. Normally the angle of contact for mercury is around 135, not 120. However, since it is given so in the question, let's take that. It says a narrow tube of radius 1 mm made of this glass is dipped in mercury. By what amount does the mercury dip down in the tube relative to the liquid surface outside? This is a very simple, straightforward question just to get you a straightforward practice. Okay, some formula based practice. Again, mains will ask you questions like this. Mains does ask you direct formula based questions. Okay, so just give me an answer quick. All you have to do is apply the equation. Okay. I hope you remember the equation. Height h is 2t cos theta over rho rg. That is it. That is all you need to apply here. Again, all you need to remember is just take your units consistent. Okay, that is it. As long as you are not, making a mess in that, you should be fine. Okay. So let's have a quick answer of this. Alright. Shouldn't be taking this long, Moisha. Okay, Rohit is also trying. He's still here. I didn't realize if he was here or not because I hadn't seen a message from him in some time. Alright, I am waiting. Don't worry, guys. Okay. Okay, so that would be 3.6 mm, right? I don't remember the answer, but I will check. Let's solve and see what we are getting. Okay. Let's give some time to Rohit also to solve this, and then let's try to see the answer. Yeah, it would be, I think, around this. 3.7 mm seems to be about correct. 3.75 mm. Alright. Maybe you took the G to be 10. It's been said here G, PQG is 9.8. Alright. So yes, that is correct. It's very simple, very straightforward. All you have to do is use the formula that H equals 2T cos theta over rho Rg. That is it. Substitute all the values 2 into 0.5 into minus 0.5. Alright. Cos of 120 would be minus of cos 60, right? Over 13.6 into 10 to the power 3 into R is 1 mm, so that is 10 to the power minus 3 into 9.8. Alright, so you will realize that H would come out to be 3.75 into 10 to the power minus 3 meters. Alright. Yeah, I figured. That's alright. Okay. So very simple again. So let's try one more thing. Let's try one more problem. So this problem tells you that water rises in a capillary tube to a height of 2 centimeter in another capillary. Yeah, see, absolutely. But here what has been asked? By what amount does the mercury dip down? Alright, so that is why we are presenting the magnitude only. Yes, of course there is a minus sign here. So yes, I only meant mod of H. Okay, don't worry. Because we had been asked by what amount does the mercury dip. The dip has already been mentioned. Alright, so please note this. So that is why we are reporting a positive answer. Okay. Alright, so next up. This problem tells you that water rises in a capillary tube to a height of 2 centimeters in another capillary whose radius is 1/3 of it. Up to what height will the water rise? Okay, so very simple. Hello Vineet, good to see you. You are very late today, 1 hour late. And then you have been told also if the first capillary is inclined at 60 degrees with the vertical, then what will be the length of water column within the tube? Okay, so you need to solve this as well. What happens if you're inclining the capillary? Okay, what will happen then? So the first part should be pretty easy. I mean, it's not even, there is no calculation required also. If the radius is 1/3, the height of capillary rise would be 3 times. Alright. Tomorrow we are starting thermo. Okay, Vineet, tomorrow we are starting thermo. Today I was just finishing up capillary rise. Okay, so we will start our revision of thermo tomorrow. So tomorrow mostly I'll probably talk about zeroth law, calorimetry and thermal expansion. Okay. So in one class tomorrow we will cover calorimetry, zeroth law and thermal expansion. Okay. Yeah, of course. 6 centimeter. 6 centimeter. Yes. It would be same 9:15 to 11:15 maybe at best. 9:15 to 11:15 maybe. Okay. Yes. So first part is very simple. Very simple. You know that height of capillary rise is inversely proportional to R. So if R is 1/3, H would be 3 times. Alright, so that is very simple. So the answer for first is very simple. Okay. So this is 6 centimeter. But what happens when you incline the capillary? Then what is the length of the water column in that? Alright, so Vineet class timing I think would be 9:15 to 11:15 maximum. 11 or 11:15 max. By the way, I don't know if you guys know this. This last class of the day is supposed to be actually only a 1 hour class from 9:15 to 10:15. I daily extend it because Moisha won't leave me if if I do not extend it to at least 1.5 hours. Okay, so let's solve this. So what do you think happens when you incline the capillary? What do you think happens then? If your capillary gets inclined like this, what happens then? No, that is not the correct answer. That is not the correct answer. Nope. Oh, that might be. Oh, yes, that is correct. Sorry. I thought we were talking about the second capillary. Yes, for first capillary. Yes. 4 centimeter is correct. So that is correctly answered by Rohit, of course. Alright, so even if you incline it, the vertical height of the capillary would remain the same. So this would still remain 2 centimeter. So because of this length would become 4 centimeter. Alright, because this is okay. So the vertical angle was 60. Okay, the vertical was 60, so this angle would be 30. So yes, absolutely correct. No problem. Alright, so that is correct. That is the correct answer. So you always remember, even if you tilt the capillary, it does not matter. The water will rise up so that the vertical height of the capillary will remain unchanged. Alright, next very interesting problem again. A capillary of length 1 meter is placed in a vessel containing water. The level of rise, okay, the level of water rise. So this should be water rise, not rise. The level of water rise in the capillary was observed to be 10 centimeters. Now this entire setup is taken to gravity free space. Okay, so this should be again gravity free space. Now this entire setup is taken to gravity free space. The new height of water column in the capillary will be seen as. So these are your options. What will happen to the height of height of liquid in the capillary if this entire setup is taken to gravity free space? Alright. Yes. Alright. Second answer was 4. First was 6, second was 4. So yes, the first was 6. This answer was 6. And the second is 4. How about this? Let's think about this. By the way, let me tell you a very interesting fact. This problem was asked in NSEJS, which is the National Science Examination for Junior Science. Okay, so class 9th and 10th students give this. I think this was asked in 2018 or 19. Okay, so this question was asked in the NSEJS. I think that is what it is called. I think so, if I remember correctly. Exam 2018 or 19. I don't remember the exact year. It was either previous year or before that. All right, now I hope you know that NSEJS exam is taken by. This is taken by class 9th and 10th students. Class 9 students mostly. So this is what is expected class 9 students to know. They expect class 9 students to know this. So let's see if you know the answer for this. Oh, by the way, this was a part of chemistry paper of NSEJS. I remember back then I was with an offline institute, and the chemistry teacher came running to me and said, "Sir, don't you guys teach surface tension in physics in class 11th?" I was like, "Yeah." And he told me, "Sir, this question has been asked and I don't know the answer. What do I tell my students?" So I had to explain this. So please give me your answers. What do you think is happening? When a capillary of length 1 meter is placed in a vessel containing water, the level of water rise in the capillary is observed to be 10 centimeters. Now the entire setup is taken into a gravity-free space. The new height of water column in the capillary will be seen as A 0 centimeter, B 10 centimeters, C 100 centimeter, or D water will start overflowing from the capillary. So tell me, I think it's been quite a long. What are you guys doing for so long? Think about it. Think about it. What will happen? What do you think will happen? Okay, I'm waiting for a response, guys. Has everybody gone off to sleep? Okay, so somebody is awake at least. So thank you for responding, Moisha. I was wondering. I thought everybody has gone off to sleep. Okay, how about others? How about others? How about others? How about others? So you're doing this experiment in a room on Earth, then the entire room is taken to a gravity-free space. Okay. So how about others? What do you guys think the answer should be? Vineet. And if there was Ankit. Yes, Ankit was also there. So what do you guys think? And Rohit Rao. Let me know your views. Let me know your views about this question. So Moisha Singh thinks it's C. Alright. Moisha says that it is not D for sure. Okay. And you never know. You never know. Moisha, do I need to remind something that in gravity-free space, when it is rising, it is not gaining potential energy, by the way. Alright. So if maybe I don't know, if it overflew, would there be a violation of energy conservation? Would there be? Answer me this. Answer me this. So in a gravity-free space, whenever the liquid is rising, there is no increase in the potential energy. So even if it started flowing, would I have a problem with energy conservation or not? Okay, so Rohit says he doesn't know. My question to Moisha is, how can you say it's not D for sure? Alright, that is my question for Moisha. Moisha said it's not D for sure. See, earlier the logic that you gave that a liquid cannot overflow from a capillary was that it would be a violation of energy conservation, which I agree with, absolutely. It cannot gain any more potential energy because it has no surface energy to take up. Alright, how about here? What is happening here? Here, would there be violation of energy conservation even if it starts overflowing? Alright, so Vineet also says C. Alright, okay. Alright. Turns out C is correct, by the way. C is the correct answer. C is the correct answer, of course. So, good that I think two of you got it right, so that is very, very fine. Alright, no problem, no problem. So, this is the answer, however. Obviously, because of the forces, you will realize that the adhesive forces, again, there is nothing to pull it further up. When it has reached the top, there is nothing to pull it further up. So even if my energy conservation is not violating, there is no reason for it to climb any further. There is no force which is pulling it up further. Alright. Hello Soham M. How are you? So that is why the answer is D. The liquid would have risen to the total height of the capillary. So would have filled the entire capillary, and then of course it would have stopped. Alright, so that is the answer. 100 centimeter would be the correct answer. Alright. So yes, energy conservation may not be getting violated. Alright. But again, there is no force also to pull it further up. Alright. Yes. Okay, so this is the correct answer. So by the way, that concludes all the discussion that I wanted to have about surface tension and capillaries. Now you guys can practice some of the problems. I hope you have done all the problems of HCV and practice some more problems from previous year. Definitely all the mains problems. Alright. Are you aware, sir, JEE Mains is happening as scheduled? Yes. Yes, I am. Okay. And it was probably gonna be like that. Once the Supreme Court had given the order, I told you there was almost no chance that now the schedule is changing. Alright. Anyhow, so tomorrow we will start our discussion of thermodynamics. Today I'll wrap it up here. Leave you guys some extra time for practice. So practice all your problems from previous year papers and your HC Verma, complete your HC Verma. Alright. And I will see you guys tomorrow. So tomorrow we will have a longish session. Tomorrow the session timings would be from 9:15 to at least 11, maybe 11:15 also, because I wanted to finish, as I said, calorimetry, zeroth law and thermal expansion tomorrow. So we will take whatever time we need to finish these three topics tomorrow. Alright, so that is it from my side. So I hope you are fine with the entire coverage. I don't think I have missed anything. I think I have covered everything that has to be covered about fluids. Alright, so that is it. Alright, so before I leave you guys, so let me remind you that you can get your Unacademy subscriptions following these very simple steps. Go to the plus section. Once you have installed the app, go to the plus section, select your goal as IIT JEE and click on get subscription. Alright. Now, as I told you that the subscription fees are already very, very affordable. You can make them even more affordable by using this code RDLive. So remember to use RDLive code while getting your subscriptions. Alright. Next, if you like today's video, if you think you learned something new, then press the like button and share it with your friends. So Unacademy is providing you not only quality education on the Plus platform, it is also providing you quality education here on YouTube completely free of cost for those students who can't even afford that subscription. So we want quality education to reach as many students as possible. So please share this video with as many people as you can. Also don't forget to press the bell icon to get the notifications of all the lectures and sessions happening here on JEE English. Alright, the PDF files of all the slides used in today's lecture would be available for download within 2 days. Okay, I have been a little lazy about it, so yes, you will have to bear with that. Now, don't forget to follow us on the Telegram app with the link above so that you're getting all the notifications of all the lectures happening here. Now, before I leave you, let me remind you, my code is RDLive. Use this code in getting your Unacademy subscriptions and enjoy another 10% off on your subscription fee. Alright, I'll see you guys tomorrow. Till then, you take care and keep practicing. Bye-bye.